All right, ladies and gents, we are going to talk about the dot product of two vectors, okay? This is easy, I promise. We're also going to talk about finding the angles between two vectors, and we're going to give you the formula, so it's just a matter of following the formula. But this is the dot product. Okay, do you see how it's a raised dot? It does not mean multiplication. It's a raised dot that's bold. Do you guys see that? On your test, it's going to say, find the dot product between, whatever. So you guys will, it's not multiplication. But what do you notice? How do you find the dot product? If I have two vectors, I have vector u and vector v. What does that little formula say?
You multiply
the first u and the first v, you multiply it together. And then you add it to the second, right? Dot product. You take first times first and add it to second times second. Does that make sense? Okay. We're going to talk about other different things here. Do you notice how v times v is just v? When they ask you for this, the magnitude, all that is just vector times vector. Okay. Again, let's talk about, because you might see this on your web assign, you might see this on a test. If I have something like 3i minus 5j, and then if I talked to you about it yesterday. If I have negative 2i plus j. All right, they're giving you the two vectors. What are the coefficients of I and j? 3 and what? Negative 5. What are the coefficients here of I and j? Negative 2 and 1. There you go. That's it. When they give it to you in that form, all it is you just have to take the coefficients. If there isn't a number, it's 1. If it's a plus in front of it, it's a positive. If there's a minus in front of it, it's negative, right? Okay. Glad we clarified that. All right, we're going to talk about a couple different things here. So finding the dot product. This is simple. Now, yesterday, some people were skipping steps. Guys, when you skip steps, I know this math is very basic, but a lot of you were making really silly mistakes with your addition and subtraction because you're skipping steps. Don't do that. All right, you know what? Actually, I want to go over a problem that's like something like this. Everybody write this down. So u is negative 2, 4, and v is 1, 7, whatever. Okay, say they had 3u minus 5v. Okay, lots of you were skipping steps yesterday and then telling me, I don't know why WebAssign's not giving me the right answer, but just because you were making silly mistakes, guys. If I write down, show me all of your work. If you do not show all your work, I'm not giving you credit on your test. 100%. You have to show me what you're doing. So if I have 3u, this is what I want to see. 3 times negative 2, 4, minus 5 times 1, 7. Lots of us were making mistakes here. I don't know if I distribute the negative or I leave it, blah, blah, blah. You can either leave the negative and deal with it later or distribute it at the beginning. I think it's best to distribute at the beginning. I would do this right here. 3 times negative 2 is negative 6. 3 times 4 is 12, correct? Now, I would put a plus right here, and then I would distribute negative 5. And then this is negative 35, right? Then first goes with first. So you have negative 11, comma, what's 12 and negative 35?
Negative 23. No, wait. Yes.
Negative 23, okay? Whoops, forgot the 3. Now, if you did not distribute it first, right? Let's just say, this is a side note from yesterday's because lots of people were making mistakes, right? This has nothing to do with pre-calc. This has to do with basic math and our negatives, right? Say you just left it like this. You said, okay, 3 times negative 2 gave me negative 6. 3 times 4 is 12, right? Then you wanted to keep that negative there and just distribute the 5. You can do that, guys. 5 times 1 is 5, and 5 times 7 is 35, right? Now what do I have to do with that negative sign? There's a 1 there. So this does not just become negative 5 and a positive 35. You then have to say, okay, I have negative 6, 12, plus negative 5, negative 35, which is what we got over here when we distributed it. But you have to distribute that negative. Lots of people yesterday weren't doing that and then getting the wrong answer. This is basic math, but if you don't do your basic math correct, you're going to have issues. Yeah? Okay, side note, sorry. All right, dot product. This is how you guys would show me your work. Dot product, remember, is first times first plus second times second, yes? So I have 4 times 5, right, or no?
4 times 2.
Good, pay attention, I want everybody with me. 4 times 2, first times first, plus,
5 times 3.
good, 5 times 3. All right, now dot product, guys, product, your answer. This is going to be one singular number. It's not in vector notation or anything like that. You're just going to get a number. So I have 4 times 2 is 8, plus 5 times 3 is 15. So what is the dot product of vector 4, 5, and 2, 3? I add it together and I get 23. It's just a singular value. We don't put it in any kind of notation. Make sense?
Yeah.
Okay, let's look at B. Again, I'm going to say this a million times. First goes with first. So I have 2 times 1 plus what? Negative 1 times 2. So 2 times 1 is 2 plus negative 2. And I get what? 0. Ooh, do you think that means something special?
No.
Yes, it does.
Oh, sure.
We're going to talk about it in 1 second. It's nothing. It's nothing to be. Nothing to be nervous about. All right, let's look at C. C is 0 times 4 plus what? 3 times negative 2. Okay, 0 plus negative 6 is what? Negative 6. Okay, let's come back to our dot product of 0. When you take 2 vectors and you find the dot product, and that happens to be 0, they are said to be orthogonal.
So it's called orthogonal?
And those 2 vectors are orthogonal. What that means in math terms is perpendicular. If 2 vectors, when you find their dot product, are orthogonal, their dot product is 0. If you find the dot product and it's 0, it means they're perpendicular, they're orthogonal. So on your test, you're definitely going to have a question or two that says, given the 2 vectors, prove that they are algebraically. That means you have to find the dot product. Now, if you were to graph this, okay, think about this. From the origin, my first vector is 2, negative 1, so 2, negative 1. And then the other one is 1, 2. Pretend that my drawing is amazingly perfect. What is formed right here? A 90-degree angle, right? So graphically, when you graph them, they form a 90-degree angle, which means they're perpendicular. But in our vector terms, that word is orthogonal. If you tell me perpendicular, I'm going to mark it wrong because the word is orthogonal. Make sense?
Yes.
Okay, you guys good? All right. Oh, gosh, here we go. Using properties of dot products. Okay, we're going to do 3 different problems. So A wants me to find U dot V and then multiply it by what? W. Now, this is where you guys are going to make mistakes. There's a lot going on in this problem, right? There's a lot of words, and then there's 3 different vectors. You guys just you have to take your time and be organized. If you mix up one of the vectors or a sign or something like that, then the whole problem is wrong, right? So just pay attention to what you're doing. So the first thing I'm going to find is the dot product between U and V. So U is negative 1, 3, and V is 2, negative 4, correct? And then I'm going to multiply whatever that is by vector W, which is 1, negative 2. Why did I write it backwards? 1, negative 2. All right, we're good? So let's find the dot product first. How do I find dot product again?
The first
The first times the first, so -1 times 2, right? Plus what? 3 times -4. Agreed? What's 2 times -1? -2 plus 3 times -4 is -14. So I get what?
-12.
No, I'm sorry, I was thinking ahead. I was thinking what my answer was. So I get what? -14. And then I need to multiply that by vector W. Agreed? So what am I doing? I'm going to distribute. So I am left with -14 comma what? 28? That shouldn't take us so long to do. 14 times 2. No, you're not. Don't say that. Okay, what does B say to do? What is B? U times the dot product, or U dot product to V. So what am I doing here? Okay, we're going to multiply 2 times vector V, then find what? The dot product, right? So U is -1, 3. What's V? 2 -4? Okay. So what would we do first, guys? Would we distribute or do we find dot products? Let's distribute. Good. So I'm going to distribute. I have -1, 3. And then I have 2 times 2 is 4. And 2 times -4 is -8. Do you see all of the work that I'm showing? This is super basic computation, but I need to see your work. You guys have got to show me work. Show. Now, if I find the dot product, it's first times, so -1 times 4 plus what? 3 times -8. So -1 times 4 is -4. 3 times -8 is -24. So what is the answer here? -28. Perfect. Questions? Everybody okay? Everybody's good?
That's the magnitude, right?
Okay, C says, what does that mean again? Magnitude. All right, what is U? What is vector U? Vector U is -1, 3. Can you guys remind me how to find the magnitude when you're given the vector? Square root of -1 squared plus 3 squared. Yeah? What's -1 squared? 1 plus 3 squared is 9. So the magnitude is the square root of 10. On your test, it's going to say find the exact value. All right, let's just say I had square root 52 and I want the exact value. If I do that in my calculator, if I hit second square root 52, I get 7.211102551. Is that an exact value? No. Exact value, guys, means to do what? Not necessarily a whole number. If I have a square root, is this a perfect square? No, so what do? I have to break it down into a perfect and non-perfect square. This would be 4 and 13, right? So square root of 4 is 2, root 13. That's the exact value. Exact value with square roots means leave your answer in a square root if it's not a perfect square.
So exact value, like right away.
All right, the angle between two non-zero vectors is the angle theta. Between their respective standard positions, vectors are shown as blah, 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 right? All right, we are going to figure out what this angle measure is. We're going to find out what this angle measure is. They're going to give us two vectors, and we're going to figure out what the angle measure is. On WebAssign, they might give you the angle measure, and you have to figure out the vectors. You just work backwards. There is a formula for this. Okay, there is a formula. You will be given the formula. Here is the formula. Before you guys look at this and go, what? It's not a big deal. What is the numerator? U and V. What does that mean? Are we multiplying them together, or what are we finding?
The dot.
We're finding the dot product. Good. So it's the dot product of the two vectors divided by what? The magnitudes
times the magnitude of v, right? So
multiplied. So all this, I can't spell multiplied. The numbers might get a little yucky, but no big deal. All right, you guys have a calculator. It's not a big deal. Yes, sir.
So if like the bottom ends up being the square root or something, then we have to just like.
Yeah, you'll see. I'll show you. Right. You'll have your calculator. Yes, sir.
What's the dot on the denominator? Like, what does that say?
It's a period at the end of the sentence. Yeah, yeah. All right, here we go. Okay, how do we find the angle between? Again, let's write it down. It's cosine of theta. So what does that mean if my formula says cosine theta? What am I going to have to do at the very end? Am I finding theta? No, I'm finding the cosine of theta. We just did this on our law of sines, law of cosine. So if I get an answer and it says cosine theta equals, what do I have to do in my calculator? I have to do cosine negative 1. I have to hit second cosine. All right, so it's the dot product of u and v over the magnitude of u times the magnitude of v. All right, now however you guys do this, it's up to you, but I personally think you should write everything out. I'm going to write out the dot product before I do anything. I'm not doing anything in my head. I'm just going to write it out. How do you find the dot product again? First times first, so it's 4 times 3 plus what? 3 times 5, correct? All right, and then on the bottom, how do you find the magnitude of u?
U squared.
Okay, so 4 squared plus 3 squared, right? And the magnitude of v would be 3 squared plus 5 squared. Does everybody agree with me? Okay, once you get that, now you guys can go through and simplify. That's fine. So I'm going to just say, okay, cosine of theta equals, well, 3 times 4 is 12, right? Plus 3 times 5 is 15. Everybody agree? Okay, now here, I'm going to just simplify a little bit. 4 squared is 16, and 3 squared is 9, right? So I get what? Square root 25, okay? Times 3 squared is 9, plus 5 squared is 25. What's 9 and 25?
34.
Times the square root of 34, okay? So simplify a little more. Cosine theta equals, what's 12 and 15? 27 over. Now, say you had 2 square roots here that didn't simplify. It's no big deal because you guys have a calculator. But square root of 25 is 5, right? Times square root of 34. Can I write it like that? Yeah. Now, you guys can do this in your calculator. You don't have to do anything else other than your calculator.
We can leave it like that.
No, you have to you're finding the angle. So you have a calculator. Come on. So you hit in your calculator 27 divided by, remember, put your denominator in parentheses. Tell your calculator what to do. All right, so what'd you guys get? 0.926. God bless you. 0.92609. Is that the angle measure? Is that the angle measure? Yes or no? No, that's the cosine of the angle. So we're going to hit second cosine. Please stop with the ball. You're going to hit second cosine, second answer. So what is the angle measure for theta?
22.16.
22.16 what? Degrees. Make sure you put your degree measure. Now, say they gave you the angle, right? They told you that the angle was such and such. Find something else. You just put the angle where theta is in your formula. It's just manipulating the formula. That's it. Okay, we just kind of talked about this a second ago. Orthogonal and perpendicular. They mean meets at a right angle. So when you find the dot product of two vectors and their dot product is 0, then you have proven algebraically that those two vectors are orthogonal. When they're graphed, they meet at a 90-degree angle. Okay? So if it says, are these two vectors orthogonal, how would you show me that? You find the what? The dot product. So you would say 2 times 6 plus negative 3 times 4, correct? What's 2 times 6? 12 plus negative 12. So what'd you just prove? Yes. Yes. Orthogonal. Very good. Good. All right, we have another thing that they could be. All right, they're perpendicular, made at right angle, orthogonal. We just talked about this. They could be parallel.
I was gonna say.
You were gonna say. What were you gonna say?
Can I ask everybody for a minute?
Yeah, you could prove that they're parallel. They also could be neither. So if you have a problem and it says prove that these two vectors are parallel, perpendicular, neither, all right? If they were parallel, you would use this formula. If they're perpendicular, you would use the dot product, right? If neither of them work out, then whatever. But look at how do you prove that they're parallel? What do you do with the vectors? I have a vector u and a vector v. What have we said all day? Yesterday, today, first stays with first and second stays with second. So you take the first part of your u vector and put it over the first part of v. And then you put the second part of u over the second part of v. So let's look at this, right? This is what we talked about earlier today. Determine if u and v are parallel, orthogonal, or neither. You guys are going to have a question like this on your test. So first of all, let's write out vector u. What is u? It's 2, negative 2. What is v? Negative 1. Whoops. Negative 1, negative 1, right? We got that from the coefficients, correct? All right, so let's first see if they're perpendicular or orthogonal. How do I find out if they're orthogonal again? What do we find? The dot product, right? We're going to say find the dot product of u and v. So we have 2 times negative 1 plus what? Negative 2 times negative 1. Okay, so 2 times negative 1 is negative 2, right? Plus negative 2 times negative 1 is what? Positive 2. So what do we get here? 0. What did you just show to me? That they're orthogonal, okay? Let's just see. Just to see. Parallel, obviously they're not going to be. But how would I find out if they're parallel? I would put 2 over negative 1 equals what? Negative 2 over negative 1. Now simplify. 2 over negative 1 is what? Negative 2 over 1. Negative 2 over negative 1 is what? Positive 2 over 1. Are those two values the same? So you would say they're not parallel. So if you are asked to prove whether they are parallel, orthogonal, or neither, right? You have to either you use the dot product. If it works out that they're orthogonal, then you can stop there. But if they're not, then you say, okay, well, let me see if they're parallel. Take the first part of u divided by the first part of v. Set that equal to the second part over the second part. If those two values are the same, when you simplify, then they're parallel. If neither of them work out, then you would just say neither. It's just like parallel, perpendicular, neither. We good? All right, that's it.